In today's installation of INC short tips by Affinity Energy, I'm going to discuss the importance of time synchronization. Time synchronization is overlooked in specification of applications in terms of hardware and proper controls and data acquisition. What I've got diagrammed here is a double-ended substation. So again, it's a main time main, and for my particular scenario, what I'm going to do is look at the importance of a PLC that's controlling these main and tie breakers, assuming that it's looking upstream to make sure that it's got two sources of power and making sure that these feeder breakers are obviously being fed power by one of the sources at all given times. So this is a common application in a mission critical power type situation where it's important that whatever loads are below here get fed power. So why is time synchronization important? Well, time synchronization is most important when it comes to root causing or diagnosing a problem that you might have with the controls or the hardware that is being controlled. For example, in this particular scenario, this PLC is responsible for detecting the presence of power upstream and then determining when to open and close certain breakers to make sure that power continues to flow downstream. If this control scheme were to fail, or if something were not to sequence properly, one of the first things that an owner or a consultant would want to look at is they would want to look at the system, and specifically probably look at the SCADA system to determine what events occurred in what sequence. That's why we call it the sequence of events. It's important to, number one, make sure that any pieces of hardware that are reporting events to your SCADA system are on a common time base. And a common time base just means, for example, in this PLC, or for example, if it were even a smart relay, we need to make sure that the clocks within all of these devices, and not only just the CPU, but there could be a redundant CPU, that they have a common time base. And that's important because in electrical systems, when we have events, they often occur very quickly. They can occur within what we call the cycle of electricity, and we know there's 60 cycles of electricity within a second. CPUs and computers, their clocks tend to drift, and if you don't synchronize them to a common time base, when you get your information here, for example, let's say that we had source 1 here, and we'll call this source 1, and we have source 2 here. And in normal operations, this particular breaker might be closed, this would be closed, and this would be open. Well, if this were to lose power, we lost power to source 1, typically what would happen is there would be either an open or closed transition. So this breaker would open, this breaker would close, and this breaker would still remain closed, and therefore power would flow from source 2 across here, and these two breakers would continue to be provided with power. Now let's say something happened and this operation that I described did not happen correctly. One of the things that you might want to go and look at would be a couple things. You might want to see at what point in time did it recognize that there was a loss of source power. If this one, you wanted to make sure, well, did this open before that closed? Because maybe if it didn't happen that way, and this were as a result, again, if there wasn't proper protection, there might have been a fault that would cause this one to open. But in any case, these inputs are coming into this PLC, and if this PLC, whether it had one or a couple different sequence of events modules, the sequence of events modules actually usually have the interface for the clock within them. So actually, I should have drawn this like this. So there could be another sequence of events module as well here. The reason that you want to have a time base would be that typically you have a clock that's part of your system, and your clock is typically receiving its time through GPS, just like the GPS is in our watches, the GPS is in our handheld devices. It's a known time base that's accepted throughout the world, and that time base, once the clock receives that, you need to distribute that time to your devices. This protocol, which is in our industry, in the electrical industry, and also in the automation industry, called IRIG-B, is a protocol that is used over coax cable to distribute that time signal to the sequence of events, or they could be digital input modules. The reason why IRIG-B exists is A, it's deterministic. That means that once we send the signal out from this clock, we know how long and we know when it's going to arrive and be recognized by the different pieces of equipment that are connected to the clock. You know, one of the downfalls that I've seen often in our industry is oftentimes most of the devices nowadays are smart devices. So this is an Ethernet network here. And on Ethernet networks, one of the common network protocols for synchronization of time is called network time protocol. So you could have this computer acting as what's called an NTP server. And NTP stands for Network Time Protocol. So it could serve timeout over Ethernet down to the CPU. But the big difference, and the reason why you wouldn't want to use this in the electrical industry, is number one, Ethernet is what's called non-deterministic. So it actually, when you send a message out by Ethernet, you don't actually know when it's going to be received by the CPU. There's going to be what's called network latency. There could be a collision that occurs and then a reset. So in order to have synchronization of time occurring, that's why the IRIG-B standard was developed. So ultimately, again, you'll want to make sure when you design your systems that when coming to root causing and analyzing the events that occur in your system, that the time base on the devices that actually record the events is synchronized using a clock and IRIG-B protocol. That's going to ensure that all of your information that flows upstream is on a common time base. You know, you're going to be looking at a report that's going to have a timestamp. It's probably going to have a device, and it's going to have a state. You know, for example, it might, there might be month, day, year, and then it's going to go hour, minute, second, and down to the millisecond. IRIG-B typically is got a resolution of 1 millisecond. So, that's one of the things that, again, recognizing that in our electrical systems, a cycle of electricity is 1/60th of a second, or about 16 milliseconds. So again, having a 1 millisecond time resolution that you can count on is going to ensure that when you go to look at, okay, well, did this one open before that one closed? That if the clocks on these and the internal mechanisms were off by several milliseconds, you may not actually be able to definitively tell, did this occur before this occurred, because your time base would be incorrect. Very important to make sure that when you are in time-sensitive applications, or applications where when things go wrong and you need to be able to root cause or troubleshoot a problem using the sequence of events from your PLC or from your smart relays or your smart meters, make sure that you are specifying a GPS clock with IRIG-B protocol. IRIG-B protocol can be distributed to many devices, and it can actually be distributed over large distances. They make converters that will convert your IRIG-B coax signal to fiber optic, and then you can transmit fiber optic. The only thing you need to be aware of when you specify, some people think that, well, I could reduce my hardware costs by having less clocks in my system, having more distributed clocks and shorter networks. The only problem is when you go to extend this network using fiber optic, you're introducing what's called network latency, or a delay. So you have to account for that delay within your time scheme, or within your design, to make sure that that delay isn't going to introduce, again, some synchronization issues when it comes to analyzing the data. In a nutshell, that's the reason why IRIG-B is important, and why it's important to have a GPS clock whenever you're involved with time-sensitive sequence of events recording. If you have any questions, please contact us. I can be reached at aevora@affinityenergy.com.